Hey guys, welcome back to this Arduino tutorial series. So in the previous video, we tried to create a circuit in which we tried to interface a sensor to our Arduino microcontroller, but instead of using the real sensor module or instead of interfacing the sensor module with our microcontroller, we used this toggle switch to illustrate the working of a sensor with this microcontroller. For now, the state of this logic state button is set to low, and when we change the state from low to high, this LED will turn on and this process goes on. In today's video, we are going to interface an IR sensor module with our microcontroller. So let's complete our circuit first and go to your component section. In the library section, type IR sensor. You have to choose IR obstacle sensor. Just click on button OK button. This IR sensor module is of 3 pins. One pin is VCC, another is ground, and third one is the output pin. As I said that this is a digital sensor, so this have only two output state. One state is the low and another state is the high state. So let's complete the circuit first. Add a battery. Click on the battery and set its voltage to 5 volt, because most of our sensor works on the 5 volt or 3.3 volt supply for powering the module. And we are reading the state of our sensor to pin number 7. And here you can see one another pin is required, which is called the test pin. Test pin are to change the state of this output pin from low to high and high to low. We need a toggle logic state button for that. As I said, that this logic state has only as we saw in the previous video, that this logic state button or logic state option has only the two output states. One is 0, which is set for now, and another is 1. So the output pin of this infrared sensor also has the two state. So this toggle switch or this logic state switch is actually used to toggle the output pin of this sensor. So before moving to coding part, you have to add the infrared sensor library to this module. So just double click on this module. For in the program file, just click on this button, go to this PC, Windows C, program files, Lab Center Electronics, in the Proteus data library, and choose this infrared sensor tep.hex file like this, and click on OK and again OK. So this is all. So this is done. We are done with this circuit part or Proteus part. So this is a real module of infrared sensor. This LED, this white color LED is an IR transmitter LED, and this black one is the photodiode to receive this white color LED transmits the infrared radiation, and this photodiode is used to receive the information or receive the radiations that are reflected back by the object. These 3 pins are used. One is used to power, one is used as VCC, another as ground, and third one is the output pin. This sensor is also called the obstacle detection sensor, because if if any object passes within the range of this infrared sensor, the radiations that strikes with this object reflects back to the photodiode, and whenever the photodiode receives the radiation, it changes the output state from 0 to 1. So this is the basic working of our infrared sensor. So but let's go to the uh, coding part. So this is the code we have written for our previous video, in which we have declared variable a and set its value to 12, because we have connected our LED to pin number 12. C variable is used to read the data from the sensor. D variable is used to store the data. read through pin number 7 in the void setup function. In the void setup section, we have used pin number A as our output pin to power on and off, to turn on and off LED, and pin number 7 as our input pin to read the data from the sensor. Serial dot begin function is used to initialize the serial communication between user and the microcontroller. By using the digital dot read function, uh, we have read the data from the sensor, which is a digital type of sensor, and connected to digital pin. Thus we have used the digital read function. The data read through the pin number 7 is stored in the variable d, and we have set the conditions for this d variable. We are turning on the LED if no object is detected. So compile this code and copy the address of this program file. Control C, and paste it in the Arduino microcontroller. Control V. So let's simulate our circuit now. Here you can see that LED is turned off because the state of our logic state button, or the state of our logic state switch is set to 0, and that means the output of our sensor is 0 for now, or low for now. Let's change the switch state from 0 to 1. Here you can see that LED is turned on, and here the same information we are getting on our virtual terminal mode. So in this way you can interface a sensor with your microcontroller, IR sensor with your Arduino microcontroller. Just change the switch, and here you can see that LED is turned off, and this process goes on whenever this IR sensor detect any object within the range. So this is all for today. Hope you have enjoyed this video. Thank you so much for watching.